In today's video, we will derive the equation for loss of head due to sudden contraction. When there is a sudden contraction, then the streamlines converge to a minimum cross section, and that cross section is known as the vena contracta. First of all, let's see this diagram. This is the case of sudden contraction. Here, firstly, let me tell you all the sections. Like this section is the vena contracta and we name it as CC section. Then after vena contracta, this is my section 2-2, and before vena contracta, this is the section 1-1. And due to sudden contraction, eddies will start to form in this region and also in this region. Here, in this case of sudden contraction, the head loss actually occurs due to the sudden enlargement from the vena contracta to the smaller pipe. That is, after the section CC, there is sudden enlargement. And this is the reason why the head loss occurs in this case. Let's denote the velocity, head loss, and area. Velocity of the flow at section 1-1. We'll denote it with V1. Then velocity of flow at section 2-2 as V2, and at section CC as VC. Then the area of the flow at section 1-1, it is A1. Then for section 2-2, it is A2. And for section CC, it is AC. The loss of head due to sudden contraction, that will denote it using HC. And then we'll find HC, which is actually the loss of head due to sudden enlargement from the section CC to section 2-2. Like I already explained, that the head loss actually occurs due to sudden enlargement from section CC to section 2-2. And for sudden enlargement, we have already derived the equation. So that will write HC is equal to, it was V1 minus V2 whole square by 2G. Here are V1, which is VC. So we'll write VC minus V2 whole square upon 2G. Now let me just take this V2 square by 2G common. As I take it as common, I will have to divide this by V2. So it will be V2 square into VC by V2 minus V2 by V2 whole square upon 2G. V2 square by 2G into VC by V2 minus 1 whole square. From the continuity equation, we can write AC/VC is equal to A2/V2. Therefore, VC by V2 will be equal to A2 upon AC. And this we can write it as 1 upon AC upon A2. And this AC upon A2, we are calling it as CC. So this will be 1 upon CC. CC is just a constant. Therefore, HC will be equal to V square by 2G into 1 upon CC minus 1 whole square is equal to this 1 upon CC minus 1 whole square, that is K. So it will be K V2 square by 2G. Here I'll just specify that K is 1 upon CC minus 1 whole square. We are assuming that CC is equal to 0.62. Therefore, K will be equal to 1 upon 0.62 minus 1 whole square, which is equal to 0.375. Therefore, HC will be equal to 0.375 into V2 square by 2G. Now, suppose we don't have the value of CC, then the loss of head due to sudden contraction will take it as HC is equal to 0.5 v2 square by 2g. This is the equation for loss of head due to sudden contraction that you need to remember. Hc is equal to 0.5 v2 square upon 2g. This way you can derive the equation for loss of head due to sudden contraction. Thank you.